luminous efficiency of fluorescent tube is, okay, luminous efficiency of fluorescent tube is 60 lumens per watt, 60 lumens per watt, okay. From the options, option C is the correct answer. అలాగే సోడియం వేపర్ ల్యాంప్ వచ్చేసి ల్యూమినస్ ఎఫిషియన్సీ 50 to 60 ల్యూమెన్ పర్ వాట్, ఓకే. అలాగే మెర్క్యూరీ వేపర్ ల్యాంప్ వచ్చేసి 40 to 50 లూమెన్స్ పర్ వాట్, ఓకే. అలాగే నియాన్ వేపర్ ల్యాంప్ వచ్చేసి 15 to 40 లూమెన్ పర్ వాట్, ఓకే. ఫ్లోరోసెంట్ ల్యాంప్కి మనకు 60 లూమెన్ పర్ వాట్ అనేది ఎఫిషియన్సీ, ఓకే. నెక్స్ట్ క్వశ్చన్, ద ఇల్యూమినేషన్ ఎట్ వేరియస్ పాయింట్స్ ఆన్ హారిజంటల్ సర్ఫేస్ ఈజ్ ఇల్యూమినేటెడ్ బై, ఓకే. ఇల్యూమినేషన్, we have one formula, illumination E is equal to Cp candle power by distance d square into cos cube theta, okay. We can also write E is directly proportional to cos cube theta, okay. E is directly proportional to cos cube theta, okay. From the options, option C, cos cube theta, C is the correct answer, okay. Next question, what is the unit of illumination, okay. Illumination units enti, okay. Decibel, okay. Decibel is the unit of sound, okay. Sound can be measured in decibels, okay. Alage Henry is unit of inductance, okay. Alage Coulomb is unit of charge, alage Tesla is unit of magnetic flux density, okay. Alage lux is the unit of illumination, okay. Option D is the correct answer, okay. Next question, for the figure shown below, what is the value of V, okay. V value, okay. This is value of V, value of V we have to find, okay. I will redraw the circuit here. R1 is equal to 2 ohms, R2 and R3, okay. This R2 is equal to 3 ohms and R3 is equal to 8 ohms, okay. Here we have to find V, okay, plus or minus V, okay. Current through this resistor is 1.5 amperes, okay. Apply KVL here, apply KVL in this loop, okay. KVL in this loop, okay. Minus V plus current into resistance 1.5 into 2 is equal to 3 plus 1.5 into 3 is equal to 4.5, okay, plus 1.5 into 8 is equal to 12, okay, is equal to 0, okay. Minus V is equal to 3 plus 4.5 plus 12, okay. We will get 19.5 volts, okay. From the options, option C is the correct answer, okay. Option C is the correct answer, okay. Next question, the electrical energy consumed by an appliance of power rating P watts, okay, connected across a rated voltage for T hours, okay. We have to find electrical energy, okay. We know electrical energy is equal to power into time, okay. Electrical energy is equal to power into time, okay. Power is given, power is P, okay. Time is T, PT, okay. Units of power is watts, okay. Alage units of time is hours, okay. Watt hour, P into T, watt hour, but in the options they are given kilowatt hour, okay. Kilowatt hour means we have to divide the energy by 1000 into kilowatt hour, okay. Energy is equal to kilowatt hour, PT by 1000 into kilowatt hour, okay. From the options, option B is the correct answer, okay. Next question, the energy consumed by 5 ohm resistor carrying a current of 20 amperes in 10 minutes, okay. Here we have to find energy. Okay, we know the formula for energy. Okay, energy is equal to power into time. Okay, energy is equal to power into time. Okay, power is equal to I square R into time. Okay, I square means 20 square into R, value of R is 5. Okay, time 10 minutes, we have to convert it into seconds into 60. Okay, we will get 400 into 50 into 60. Okay, now we will get 12 5 zeros. Okay, joules. Okay, we can also write 1200 kilojoules. Okay, from the options, option B is the correct answer. Okay, next question. A 4 ohm resistor has specific maximum power dissipation of 784 watts. Calculate its maximum current. Okay, resistance value is given and power value is given. We have to find current. Okay, we know the relationship between power, current and resistance. Okay, power P is equal to I square R. Okay, P is given. P is power is 784. I value we have to find. Okay, R value, R is 4. Okay, 4 1 ja 4, 4 1 ja 4. Okay, 38 remains. Okay, 4 9 ja 36, 2 remains, 2 24. Okay, 4 6 ja 24. Okay, I square is equal to 196. Okay, I is equal to 14 amperes. Okay, from the options, option B is the correct answer. Okay, next question. The unit of capacitance is, okay, capacitance okay units endi, okay, volt per coulomb or coulomb per volt, ohm meter or none of the above. Okay, we have relationship between capacitance, charge and voltage, that is Q, charge is equal to, okay, CV, capacitance into voltage. Okay, from here we will get Q, C is equal to Q by V. Okay, Q means charge units are coulombs. Okay, coulombs. Okay, alage units of voltage is volt. Coulomb per volt is the unit of capacitance. Okay, coulomb per volt is the unit of capacitance. Option B is the correct answer. Okay, next question. When the capacitance of load, capacitive load is connected, then the power factor will be, okay, for the capacitive load ki power factor enti. Okay, there are 3 types of loads. One is resistive load, R load. Okay, second one is inductive load or L load, or third one is capacitive load. Okay, for resistive load the power factor is unity. Okay, for inductive load, pure inductive load, power factor is ZPF. Okay, zero power factor, lagging power factor. Alage C load, capacitive load ki zero power factor, leading power factor. Okay, leading power factor. Okay, in the question they are asking for capacitive load, there will be leading power factor. Option D is the correct answer. Okay, next question. The monthly energy consumption of 10 lamps having power rating of 100 watts each for 8 hours per day. Okay, the lamps are working 8 hours per day. The monthly energy consumption is, okay, we know energy is equal to power into time. Okay, power, what is power? 100 watts. Each bulb is having 100 watts. There are 10 bulbs. Okay, next time is daily 8 hours. Okay, 8 hours. Okay, we have to calculate for monthly, so we have to multiply into 30. Okay, now we will get 8 into 3 24 4 zeros. Okay, 24 4 zeros kilowatt hour. Okay, watt hour. Okay, 1 watt hour is equal 100,000 watt hours is equal to 1 unit. Okay, 1000 watt hour is equal to 1 unit. Okay, here we can also write 240 units. Okay, energy is 240 units. From the options, option A is the correct answer. Okay, 1000 watt hours is equal to 1 unit. Okay, we can also write 1000 unit, 1 unit, okay, 240 units. Okay, next question. If the resistance of a coil is 15 ohms and the impedance is 25 ohms, then calculate the inductive reactance. Okay, resistance value is given and impedance value is given. We have to find inductive reactance. Okay, we have one relation between resistance, impedance and inductive reactance. Okay, Z impedance is equal to square root of R square plus XL square. Okay, resistance value is given. Okay, and also impedance value is given. Impedance value is 25 is equal to R value, resistance value is 15 square plus XL square. Okay, from here we will get 25 square is equal to 15 square plus XL square. 25 square is 625 is equal to 15 square is 225. Okay, plus XL square. Okay, from here we will get XL square is equal to 400. Okay, here we will get XL is equal to 20 ohms. Okay, inductive reactance is 20 ohms. From the options, option D is the correct answer. Okay, next question. The resonant frequency in parallel tuned circuit is, okay, resonant frequency. Okay, resonant frequency. Okay, at resonance condition, inductive reactance is equal to capacitive reactance. Okay, under resonance condition, under resonance, XL is equal to XC. Okay, XL, what is XL? XL is equal to 2 pi FL. Okay, alage XC is equal to 1 by 2 pi FC. Okay, we can also write 4 pi square F square L C is equal to 0. Okay, from here we will write frequency square is equal to 1 by 4 pi square L C. Okay, we can also write F is equal to 1 by square root of 4 pi square L C. Okay, we can also write 1 by 2 pi root L C. Okay, 1 by 2 pi root L C. Okay, from the options, option D is the correct answer. Option D is the correct answer. Okay, next question. In which of the following relay is used for long transmission line? Okay, relay. Which relay is used for long transmission line? Okay, we have three transmission lines: short transmission line, medium transmission line and long transmission line. Okay, మనం long transmission line ki మనం more relay use చేస్తాం. Okay, option C is the correct answer. అలాగే impedance relay, మన impedance relay వచ్చేసి medium transmission line. Okay, medium transmission line. Okay, అలాగే reactance relay వచ్చేసి short transmission line. Okay, next question. The relationship between fusing current and the diameter D of the wire. Okay, where K is the constant of fusing current. Okay, the relationship between fusing current and diameter of conductor. Okay, diameter of the fuse. Okay, I is equal to K D power 3 by 2. Okay, I is the fusing current. Okay, K is the constant of fusing constant. Okay, alage D is the diameter of fuse. Okay, from the options, option A is the correct answer. I is equal to K D power 3 by 2. Okay, next question. In a short circuit test on the circuit breaker, the following readings were obtained on single frequency constant. Okay, time to reach peak restriking voltage is 50 microseconds. Okay, and the peak restriking voltage is 125 kilovolts. What is the average rate of rise of restriking voltage? RRB. Okay, we have a formula for RRB. RRB is equal to, okay, peak restriking voltage by peak restriking voltage by time to reach peak voltage. Time to reach peak restriking voltage. Okay, peak restriking voltage is 125 kV. Okay, 125 kV, okay, by, okay, time to reach peak restriking voltage is 50 microseconds, okay, 50 microseconds, okay, 25 2s are 25 5s are, okay, 5 by 2 means 2.5 kilovolt per microsecond, okay, 2.5. From the options, option B is the correct answer, okay. Next question, the power in sub circuit, the load not more than, okay, power sub circuit la, okay, power sub circuit la load anedi maximum load అనేది ఎంత వరకు ఉండొచ్చు, ఓకే, పవర్ సబ్ సర్క్యూట్ లో మనకి 300 వాట్స్ వరకు ఉండొచ్చు. అలాగే ఫ్యాన్ అండ్ లైట్ సర్క్యూట్లో, ఓకే, మ్యాక్సిమం పవర్ లిమిట్ వచ్చేసి 800 వాట్స్, ఓకే, పవర్ సబ్ సర్క్యూట్లో 300 వాట్స్, ఓకే. నెక్స్ట్ క్వశ్చన్, ద ఫ్రీక్వెన్సీ ఆఫ్ ఏసీ సప్లై యూజ్డ్ ఇన్ ఇండియా ఫర్ డొమెస్టిక్ పర్పస్, ఓకే, ఫ్రీక్వెన్సీ ఇన్ ఇండియా ఫ్రీక్వెన్సీ ఈజ్ 50 hertz, Indian frequency is 50 hertz, okay. Next question, what is the number of such switches which are used for lighting circuit? Staircase wiring, okay, మనకి staircase wiring అంటే one bulb can be operated by using two switches, okay, here we will use two-way switches, two-way switches, okay. Staircase wiring la one bulb can be operated by using two switches, okay, here we will use two-way switches, okay. From the options, option B is the correct answer, two-way switches, okay. Next question, if the temperature of the conductor is increased, okay, temperature of conductor is increased, then its resistance will be increases, first decreases, then increases, or will change according to the season, okay. మనకి 3 types of metals అనేవి ఉంటాయి, electrical metals, okay, conductor, semiconductor and insulator, okay. మన కండక్టర్ వచ్చేసి పాజిటివ్ టెంపరేచర్ కోఎఫిషియంట్, ఓకే, semiconductor and insulators are negative temperature coefficient metals, okay. Here when temperature increases, resistance also increases because conductors are positive temperature coefficients, okay. Here when temperature increases, okay, resistance will decreases, okay. In the question they are asking about conductor, when temperature increases in the conductor, resistance also increases, okay. Option B is the correct answer, okay. Next question, the resistance of insulating material, okay, the resistance of insulating materials are negative temperature coefficient materials, okay. If temperature increases, the insulation resistance will be decreases, okay, proportional to its resistivity or depends on its temperature or independent of temperature, okay. Insulating materials are negative temperature coefficient metals, okay. If temperature increases, okay, resistance will decreases, okay. Resistance of insulating material will depends on temperature, okay. Option B is the correct answer, okay. Next question, what is the full form of VIR, okay. VIR full form వచ్చేసి vulcanized Indian rubber, VIR full form వచ్చేసి vulcanized Indian rubber, okay. మనం vulcanized Indian rubber లో మనం 3 to 5% ఆఫ్ సల్ఫర్ ని యాడ్ చేస్తాం, సల్ఫర్, ఓకే. మనం ఈ సల్ఫర్ యాడ్ చేయడం వల్ల మనకు రబ్బర్కి వచ్చేసి మెకానికల్ స్ట్రెంత్ అనేది ఇంక్రీజ్ అవుతుంది. టు ఇంక్రీజ్ మెకానికల్ స్ట్రెంత్, ఓకే. Full form of VIR is vulcanized Indian rubber, okay. Option B is the correct answer, okay. Next question, in cables charging current is, okay, lags voltage by 90 degrees, leads voltage by 90 degrees, or lags voltage by 180 degrees, or leads voltage by 180 degrees. What is charging current? Charging current is capacitive current. Okay, charging current. Charging current. Charging current is current stored in capacitor. Capacitive current. Capacitive current. Okay, it will be current will be leads voltage by 90 degrees. Leads voltage by 90 degrees. 90 degrees. Okay, from the options, option B is the correct answer. Okay, next question. The size of the conductor of cable depends on, okay, size of conductor will depends on insulation, current, voltage or power. Okay, manaki size of the conductor అనేది size of conductor, okay, depends on current. అలాగే insulation level, insulation or distance between two conductors, insulation or distance between two conductors, distance between two conductors will depend on voltage. Okay, size of the conductor అనేది మన కరెంట్ మీద డిపెండ్ అవుతుంది. అలాగే ఇన్సులేషన్ ఆర్ డిస్టెన్స్ బిట్వీన్ టూ కండక్టర్స్ అనేవి మనకి వోల్టేజ్ రేటింగ్ మీద డిపెండ్ అవుతాయి. ఓకే, హియర్ ఇన్ ద క్వశ్చన్ దే ఆర్ ఆస్కింగ్ సైజ్ ఆఫ్ ది కండక్టర్. సైజ్ ఆఫ్ ది కండక్టర్ విల్ డిపెండ్ ఆన్ కరెంట్. ఆప్షన్ బి ఇస్ ద కరెక్ట్ ఆన్సర్. ఓకే, నెక్స్ట్ క్వశ్చన్. విచ్ ఆఫ్ ది ఫాలోయింగ్ ప్రొటెక్ట్స్ ద కేబుల్ అగైనెస్ట్ మెకానికల్ ఇంజురీ? ఓకే, కేబుల్ మెకానికల్ ఇంజురీ నుండి కేబుల్ని ప్రొటెక్ట్ చేసేది ఏంటి? ఓకే, ఆర్మరింగ్ విల్ ప్రొటెక్ట్ ద కేబుల్ ఫ్రమ్ mechanical injury. Okay, next question. Which of the following type of insulation cable is used in underground system? Okay, type of insulation cable is used in underground cable. Okay, that is 133% insulation level is used in underground cable. Okay, thank you so much.